Okay, so once again, good afternoon, everyone. It's 6:05, and we are going to start the class. I'm going to share my screen first. Okay, so I hope all of you can see my screen already. Can you hear my voice clearly? I hope so. I'm trying to talk more, talk slower. All right. So last time, about a few weeks ago, I think we were learning about transition metals, there are a lot of them. But I think we are going to skip that for a while. We are going to discuss about the halogen group, what kind of characteristics they have, and what kind of elements that exist of the halogen group. So there are only a few elements, and we're going to discuss only about the halogen group for today. And probably we're going to move on with noble gases. Why do I pick alkali metals, earth metals, halogen, and noble gases first? Noble gases probably after the halogen group because those are the most common elements of the periodic table. And we're probably going to continue to transition metals after reviewing noble gases and other groups such as the boron group, carbon group, and nitrogen group, which are way more common than the transition metals itself. Well, we already discussed some of the common elements in the transition metal as well. The rest are really known. Okay, so we're going to move on to the halogen group. So click this. Okay. So there are 6 elements in the halogen group, which are the 6 that we are going to discuss in our today's class. And I think I've mentioned this in the group already. This class won't be long since I'm preparing for tests. So it's probably for about 30 minutes or to 40 minutes at most, and I will end the class. Okay. So the halogen group is one of the most reactive groups in the periodic table, aside from the alkaline metals. This includes nonmetals. The name halogen means salt former, which refers to the way the elements in the group react with metals to form salts, such as sodium chloride. Sodium is actually Na or natrium. We said it's actually one of the alkaline metals. And then chloride is one of the halogen group, which is from chlorine. And the two can be very reactive. That's why they react rather easily. And this is actually one of the most common compounds sodium chloride, or we know as salt, that we commonly use. And then scientists don't know much about tennessine, TS, and artificial halogen. So TS, artificial halogen, is not very common. So it's value studied at the submarine period here. Okay, so here are the 4 characteristics. So first of all, we have the atomic structure. All members have 7 electrons in the outer shell of each atom. There is space for 1 more electron in each outer shell. And then we have physical properties. Bromine, or Br, is the only halogen that is liquid. Fluorine and chlorine are gases, while iodine and acetine are solids. So physical properties in halogens vary, can be in the form of liquid, solids, and even gases. And then for the chemical properties, we have every halogen atom receives 1 electron from other atoms to form a compound. Activity decreases down the group. And then, so, okay, just trying to emphasize that halogen atoms tend to receive 1 electron from other atoms to form a full compound to make the element balance with the balance. And then the compounds, we have the halogens react with hydrogen to form acidic compounds. Halogen compounds are used in products such as bleach. So the first one in the periodic table in the halogen group, we have fluorine, which has atomic number 9. And here's some of the laboratory samples is in this shape because it's actually in gas form. It's not solid nor liquid, so it's gas. So here are some minerals. Topaz means fire in the ancient Indian language of Sanskrit. Interesting fact. So here it's this. So this highly reactive element is incredibly dangerous when pure. So we know that fluoride right here is fluorine right here. It's incredibly dangerous and it can kill a person even though it's in tiny amounts, meaning that this element is considered as toxic, meaning that it is dangerous. Then and because it is dangerous, full fluorine is often stored in nickel containers that can resist its attack. Okay, metals such as cryolite and fluoride contains this element. This gas and its less harmful compounds have a wide variety of uses. Hydrofluoric acid is a toxic liquid used to etch patterns in glass, as seen in some glass vases. Right there. Anyway, you hear the vase over there? As you should say. So here are some uses of fluorine, as you can see right here. Here's some examples, as you can see. I'm going to give you some time to look at the picture. Another compound called polytetrafluoroethylene is commonly used to make non-stick pans. And this material is slippery and food that has burned while cooking from sticking to the pan. Thin fibers made of this compound is also used to make waterproof clothing. So fluorine is also used like the most common thing that we use every day is toothpaste. And the use of this is actually to prevent decay in a teeth. So a toothpaste contains fluorine for the thing to decay, something. This is some history about fluorine in the early 80s. Chemists in Europe, 18s, something. You realized that minerals such as fluorine contain an unknown element. However, it took another 70 years for the French chemist Henri Moissan extracted pure fluorine following a series of dangerous experiments that even poisoned him several times. So this is how early scientists found out that fluorine is a toxic element, meaning that it's dangerous and can kill poison. And now we have chlorine here, which is also gas. Okay. Okay, so here's this. Okay. So just note that every elements in this halogen group are very reactive, but they somehow decrease as we go down the periodic table. All of them are still considered reactive compared to the other elements in other groups. Okay, so chlorine is a highly reactive gas. It forms a number of compounds and doesn't exist in pure nature. The most common chlorine compound is sodium chloride, from nature as the mineral halide. Chlorine compounds are important for the body and are used by muscles and nerves. They are also present in sweat as it is poisonous in its pure form. Chlorine gas was used as a weapon during World War I. So technically they're the same. Almost elements, they're actually kind of has meaning that's dangerous for human and some of them can kill. This is why we need to take precautions when experimenting with elements. Okay. So there's a term called chlorination right here, which is a process of cleaning dirty water with chlorine. So here, the process, you can see it right there. And why is it dangerous, however, when react, for example, with sodium from the alkali metals, which is also a reactive element? It can they mix together and make the compound, create a compound, just common salt, sodium chloride, and it is definitely safe to eat. So it actually depends on what element does an element react. So it actually depends on this toxicity. Okay, so here are some other examples of the use of chlorine. So, so all of you probably noticed that when swimming in a swimming pool, there's a distinctive smell. Well, because a weaker chlorine acid is used to clean water in swimming pools, while bleach and other cleaners use chlorine compounds to kill germs. So chlorine acid is actually useful for cleaning water in swimming pools. That's why they have this smell, which is a chlorine smell. And this is why we also not to drink any of the swimming pool water because it can be sort of poisonous, but not poisonous that can kill, not to that extent, but still um contains chlorine, which is not good to consume. So here are the others. So chlorine is a common ingredient in cleaning products. It can be used for scrubbing everywhere from bathroom tiles to ocean floors. So here, yeah, the example that I've told before. So just we can skip that part. Okay, so we are up to the third element. Okay, we have about 15 to 20 minutes. Okay, so we're going to speed run this. So you have bromine for the next one to make number 35. So this time bromine is in liquid form, unlike the previous two which are in gas form. So bromine is the only non-metal that is a liquid at room temperature. Okay, so pure bromine is never found in nature. Its compounds can easily mix in water and are found dissolved in seawater and in extremely salty lakes such as the Dead Sea. Okay, so here are the uses as well. We have here like iron extinguisher. So most of them are used in weapons as weapons in World War. So a common use of this element is as a disinfectant to clean water. It is better than chlorine in hot tubs as chlorine escapes into thin air easily from the warm water, well, because its original form is in gas, so of course it can evaporate easily. The contamination of bromine in swimming pools can be regulated using chemical test kits. Bromine compounds can be used in film photography in which images are printed using chemicals on negatives. And today bromine is mainly used in fireproof material. And the reason is because it doesn't catch fire easily, meaning that it doesn't really catch fire. Yeah. That's why this suit is used, bromine is used to make this fireproof suit. So now, next one, the fourth element, we have iodine, which as you number 53, and the symbol is I only, spelled I. And now it's in solid form. And the sealed glass container prevents iodine from reacting with air because it's highly reactive. That's why it needs to be sealed. And solid iodine doesn't melt, but it but when heated, it turns into a vapor. Okay, even though it's solid, it won't melt. And colored ink for printing inks are made using iodine compounds as well. So iodine is the only solid halogen is solid in room temperature. Okay, so seaweeds, many plants and animals in the sea have high levels of iodine. Interesting. Including crabs and fish provide evidence that the human body needs small amounts of iodine to make an important substance called thyroxine, which helps us grow. So thyroxine is actually one of growth hormones, and that's why it's important. So it's also used in disinfectant and food dyes. Okay, so y'all, of you probably noticed that disinfectant, which is betadine that we use when to stop wounds from bleeding, there's actually disinfectant applied to stop the spread of infection. Yeah, it also contains iodine. So actually, some people even call this betadine as iodine because, well, it's actually the main ingredients of that. Okay, so it's actually so okay. So now the next one would be noble gases, and since we have still time, I think I'm going to just give a rough review of the characteristics. And yeah, so acetylene and what is it called? The tennessine is actually not very common. I almost have never heard of tennessine before because, well, it's even very old. Anyway, atoms of astatine are stable and typically break down after just a few hours into atoms of lighter elements such as bismuth. So bismuth is actually a very colorful um mineral actually. I think it's a mineral. I'm not sure it's solid form actually, but it's really beautiful. We can search it out. This radioactive element itself forms in a similar way when atoms of a heavier element called francium break apart. Tiny amounts of these rare elements are found in uranium ores such as uraninite. The Italian physicist Emilio Segre was one of the first scientists to isolate a sampler of pure acetylene. He was able to do so by using a particle accelerator. This is a machine that smashes together atoms and then studied the results. So here, acetylene 80 right there. See this? We have tennessine right here. So atoms of tennessine exist for a few seconds after they were formed. So of course, why the name tennessine? Because it is actually found in Tennessee. So sometimes they name elements based on that. And for example, germanium, I assume that it's actually discovered in German. And then we have selenium, which is an element that was discovered by Einstein. So sometimes elements are like that, or maybe they could just be named after the Latin name. For example, we have okay, which is I think it's calcium. Or we call them potassium, for example. Yeah, I think it's the Latin name. So there are a few examples. Okay, anyway. Tennessine is the youngest element in the periodic table. It was produced in 2011 in the Russian city of Dubna. The element was named after the US state of Tennessee, home to the Oak Ridge National Laboratory. See, so it's named after Tennessee, which housed one of the first large-scale nuclear reactors ever built. So, okay, it was produced in Russian City, but the element was named after Tennessee, which housed one of the large-scale reactors ever built. Okay, so it doesn't really made Tennessee, but they were named after Tennessee because of the nuclear reactor ever built, because the large scale nuclear reactors ever built was there in Tennessee. Um, Specifically the Oak Ridge National Laboratory. So that's how tennessine got its name. Only a few atoms of this halogen element have ever been made. If so, studies have predicted it to be a semi-metal, not a non-metal like all the other halogens. So it's a semi-metal, meaning that it's half metal and half non-metal. meaning that it has both characteristics. So I think we have about 5 minutes more. So I'm just going to review halogen for a while. Okay. So for the noble gases, we actually have 7 elements. This I think we're going to discuss further in our next meeting. Okay. Just a little bit of overview about noble gases. So the group on the far right of the periodic table belongs to the noble gas. It's actually in the, I think, 18 group, which is the very last there. These are described as noble because they do not react with the other common elements. Okay. So it's actually named after that. Common elements, it's not actually they're noble in any sense. It's just that they are highly stable, meaning that they do not react easily with the other elements that are very reactive, like alkaline metals or halogens. Such as oxygen, their atoms never form bonds in nature, not even with atoms of their own kind. So they're always gases at room temperature. So that's why it's called noble gases, because all of the groups, the noble gases, they're all gas. None of them are liquid or solid or anything. They're all just gas, mostly. And okay, so we have the characteristics right here. So the atomic structure, apart from helium, and it has 2 electrons in its outer shell, all other elements in this group have atoms with 8 electrons. But helium is still considered stable because, yeah, still have the 2 room right there if we draw the valence electron. And physical properties, all the this group are colorless gases, meaning that doesn't have any colors. And going down the group, the density increases. Radon, for example, is 54 times denser than helium. So helium is actually the very top of the elements. Yeah. Then for the chemical properties, we have noble gases never react in nature. In the laboratory, heavier noble gas can be forced to form compounds with fluorine. So fluorine is actually the halogen that we previously discussed a few minutes ago. And well, it's kind of like neighboring though, because fluorine is number 9 and neon is 10. It's pretty close. And that's why in laboratorium where humans can intervene with um the, the reactivity of noble gases, then yes, they can actually force them to form a compound. But in nature, uh, they will not form a compound in nature. Anyways, and then the compounds right here, the gases from known natural compounds. So most of them are natural. However, xenon, Xe, krypton, and argon can be made to form compounds. So technically, the argon, xenon, and krypton, they're written like the third to fifth period. And based on what I've studied in high school, right, the helium and neon, they don't have any compounds, meaning that we found them in pure form in nature. They don't have any compounds. So these gases form no natural compounds, like this book said. But yeah, those trees have their own compounds, even though they are rare. But helium and neon, they don't have any compounds, meaning they can form. They can bond with any other atoms in the periodic table. Okay, so just a fun fact right here, just to kill time a bit. So helium is the second lightest element after hydrogen. So take note that the first there are only 2 elements right here. I'm going to show this. So this is should be hydrogen, the one is this blue box right there, and this is helium. So the 2 in the first period are by the lightest elements in almost every periodic table. So hydrogen is the lightest, and then helium is the second. So just a little fun fact about that. And I think we're going to discuss this later on. Probably going to give, and I'm probably going to test out by giving a quiz about halogen the next week after noble gases. I think that's all from me today since I need to prepare for my test as well. I'm going to stop sharing my screen for a while and I think I need to stop recording.